So, hello guys and welcome to Automation. Automation is a game which is currently in beta, which is being designed by a group of guys called Camshaft Designs, something like that. And which I discovered some hours ago, some long hours ago, because I have been hooked into the game for a long time now. I discovered this in Steam Greenlight, and this is currently in beta. This is in development, and it doesn't currently have yet a release date. This is intended to be a tycoon game in which you take command of car industry and design your own cars, your own engines, your own everything. Research new parts, build cars, and sell them. If you guys have an age, and if you have been gaming for a long time, you might remember a pretty old game by today. In the early 1990s, in 1993, I think more or less, it was called Detroit, which was from Sierra Online Systems. That was basically the same concept, a tycoon game where you could design your own cars and then market them and sell them. But this is so much more evolved. This is in the technical sense. I mean, in that game you simply put parts, and it was a tycoon game. It was nothing like. But this is so much into the technical aspects of car designing and engine designing. So if you are a motorhead, which I am, well, actually, I discovered I have to spend some time before being a true motorhead, because I thought I knew something about engines, and after playing this game, I know I don't. If you are a motorhead, this game is for you. It's so impressive. Right now, as I told you, it's in beta, it's in development. Um, it's no by no means and by far complete. I mean, right now you only can design your engine. You can't even start designing your car, but that is coming soon. There are several ways of trying this game. The first of all is well, just downloading the beta. They have a working beta, which is actually incredibly fun. Which is the engine design part, with some parts which you can't access because, of course, it's free. And then you can pre-order the game. And of course, pre-ordering the game means that when it's released, you are going to get it. But also, you get more goodies. You have early access to things as they are released. And yeah, I actually pre-ordered this, and yeah, I did. There are two options to get a pre-order. One of them is $25, and the other one is 35. I went with the 25 because I can't spend a lot of money, but that's more than enough. Um, the good thing here is that by just giving that money, you are not just ensuring that you will get the game, but also you get goodies um, sooner as they are being released and before they are included in the working betas. Right now, as I told you, you only can access the engine scenarios. There are tutorials, well, actually, there are tutorials in line for engines in the beta. In the pre-order version, you have V8 engines and general scenarios. We are going to go with an inline 4 engine, and you're going to see what I mean by technical. This is more than technical. This is, well, these scenarios are challenges where you get some limitations and technical specifications of an engine you have to build. And the better you build it and the more points you score, the better you are going to qualify. There are bronze category, silver category, gold category, and then platinum if you do it super well. And it's a huge challenge to build the engine that they are asking you to build, and then to refine it to achieve platinum with it. Believe me, it really sucks you up and doesn't let go until you really get your objective done. So let's get started. Let's go with this one. This one I already played. So I haven't played this one, so we are going to do this together. It's an easy level. So well, Moscow, 1950. Your government-owned automobile plant has received a requisition from the Army. They are designing a new light off-roader which requires a simple, torquey, and practically bulletproof engine to power it. Yeah, sounds Russian. Can you give them what they want, or is your next assignment going to be in Siberia? Well, you have several limitations here, and you have your objectives. The limitations here: manufacture year 1954. This gives you access to more or less parts depending on the year, and the parts have more or less resistance depending on the year. Regular leaded. This is the fuel you are going to use. A limit of 3000 RPM. And the technical specifications of the engine you have to achieve. More than 100 Newton of torque, a manufacture time of less than 23 hours, a mean time between, I think this is revisions, I don't know what the F stands for, but yeah, higher than 31,500 kilometers, weight lower than 190 kilograms, and loudness less than 55. You can see there's a percentage here, and this is how much the score is going to be weighted around these variables. So getting more torque gives you more points, but not as much as if you get a much higher MTBF or a less manufacture time than 23 hours. So we'll deal with that later. So let's play this scenario and see what we come with. Jeep drives you. Okay, we need 1000 to bronze, 1384 for silver, 1662 for gold, and 1864 for platinum. So, yep, let's go. And this is your workshop. Here is where you design your engine. You have a dynamo here. This is a static bench, basically. So, well, let's get started. Well, we are going to do a very simple tractor or Jeep engine, so we'll have the option to get an inline 4-cylinder engine. Actually, this is for this scenario. In others, you have V8s, flat V8s, inline 6 engines. So I mean, there are a lot of more options in other scenarios, but for this one, you only can go with cast iron inline 4-cylinder engine. And there it is, our engine block, which already weighs 61.4 kilograms, and that's a lot. Okay, the bore and stroke, we don't really have a limit on that. And we don't really need horsepower, we need torque. Okay, let's try with 1500 centimeter cubic, like this. Yeah, actually like this. Bore stroke. We are not going to have a huge lot of RPM, so we can really go with like mad with the stroke. Well, maybe not that mad. I'll reduce it a little bit. The higher the stroke, the more problems you have with high RPMs, but as we have a limit of 3000 RPMs, that's not going to be a problem. Okay, we are going to reduce this a little bit. A 2-liter engine, more or less. Yeah, like this, 1.9 liter engine. And the crankshaft is going to be cast iron, you can see it there. We have the connecting rods, which can be cast iron as well, or heavy duty cast. I'm going to go with cast just because it weighs less. But actually I'm going to go with heavy duty because this stands torque better, and we are going to need that. Pistons, we can go with cast and heavy cast. So again, heavy cast, because we need torque, not high RPM. That's the bottom end of your engine. And you saw the engine block before. So if you want to see everything mounted, there you go. There you have it. Top end. Head and valves. I'm going to go with a simple arrangement here. A direct acting overhead cam should be enough. You can go with a overhead cam, dual overhead cam, but I'm thinking that again we are not going to go over the top with RPM, so a couple of valves is going to be enough, and we are going to save a little bit of weight with that. Cast iron. Well, actually, I don't know if I want to go with push rod. Hold on a second, because that's going to save some weight. But friction is very high now. That's too simple, and weight saved is not that much. So yeah, let's go with that. We don't have any other option. In other scenarios, you can go with aluminum, magnesium, but in this one we'll have cast iron because we are in 54. So yeah, compression radio, we are going to leave it at that. Cam profile, we are going to leave it at that. Actually, no, we are going to lower it because low cam profiles favor low-end performance, and we are not going to be at high RPMs. We don't have variable timers for valves, so no big worries here. So none. And well, you can improve the aesthetics. That's the engine as it looks right now, and you can change the style of the engine. Put the color you want. Red. Yeah, it's for the Soviet army, so red fits well. Expression. Naturally aspirated. We don't have access to turbos, and really, why do you want a turbo for in a tractor engine? So yeah, whatever. Fuel system. We only have access to carburetors. In other engines, you have access to direct injection, and with a lot of different options with direct injection. But again, 9454, not direct injection, only carburetor. We can go with single barrel or two barrel. The difference is a little bit more of weight, but I'm going to take that because I want a little bit more of performance. Single carburetor, the intake of the carburetor, which is here. Well, we can go with performance. Has some noise reduction. We need loudness less than 55. I'm going for performance. Yeah. Fuel regular leaded is what we have here. RPM limit, we are going to limit as specified to 3000 RPM. Fuel mixture, rich or lean. The richer, well, you are going to see later. I'm going to explain that later. Right now, just go with me and let's leave all of this like this. These are the exhaust systems. Cast log, short cast, tubular, long tubular, raised tubular. We want to go simple here. We don't really need something really fancy. We can make with a short cast, with a single exhaust, and no bypass valves. Exhaust diameter, we are going to select that later. No catalytic converter. First muffler of reverse flow and a second with none. These are the exhaust mufflers that rule the noise reduction. Actually, we are going to go with two reverse flow. Those restrict airflow a little bit, but they reduce noise reduction. Actually, I go with baffled. If I'm going to use two, yeah, like that. And now we go to test the engine. That's our engine. That's complete. And now let's see how it does. First, we can go to manual. There's the diagram of how the engine works, from the intakes, the pistons, the connecting rods, etc. If there is any trouble with any of these components, we will see here that it's going red. So let's start the engine and throttle up. Ooh, something broke. The engine failed due to knock. Try lowering the compression. Okay, let's see what happened. Start. This is automatic. This is a dynamic analysis of the engine. You can see, yeah, it breaks away here because the fuel octane rating is insanely high. So what we want to do is probably low the compression ratio. We don't need a very big compression ratio anyway, because this is not a high performance engine. So we are going to go with 7.5, which should be enough. And let's test it again. Yeah, now seems it works without any problem. Fine. Okay, we are seeing here what we have achieved. The engine is still knocking. So what we want to do here is to increase the reach, the fuel mixture, because the richer you go, the higher anti-knockback effect you have. The problem is that if you go too rich, you leave some fuel without burning, and you create problems with full power, and yeah, it's problematic. So you don't want to go too rich. Let's test it now. Now we should have no problems with fuel octane. Torque is 94, has improved a lot. The richer you go, until a point increases your torque. Okay, a bottom part is reducing the MTBF as it's starting to reach its RPM limit. This is worrisome. Or maybe not. Because if we change which part, okay, hold on a second. Let's see which part is failing. Alright, there you go. It's the connecting rods. So let's stop this, go to the connecting rods, put it cast so it can hold more RPM, and test it again. By the way, you can see here the engine working. And now it's working perfectly fine. Nice. Stop it. And let's go to the dynamic test. And see what we have right now between our hands. We only need to increase the power and we will meet the technical specifications. Okay. The engines on reeds are reducing the power output. That's what I told you. When you go to reeds with the fuel, you pay for that. Let's reduce it a little bit. We are well within below 92, which is our fuel octane limit, so we shouldn't have any knock effect in this one. Let's see. Okay, we went over the limit here. Yeah, success. We got a silver ranking straight away, not bad. We have more torque than what they asked us. Manufacture time is less than 23 hours, which is giving us a good score. NTBF is higher than 31 kilometers, so score. Weight lower than required, and loudness is low enough. So let's make it better. We can improve that. First of all, let's try to quit this and see what happens. Loudness will go a little bit up, we will get a lower score, but hopefully that helps with top power. We will see that. See how the loudness is changed? Oh, went over the limit, so we have no chance to do that. But, okay, another thing we have to do, exhaust diameter. The larger the exhaust, the bigger the noise. So this is very simple. Testing. We are achieving 50 horsepower. So if we select an exhaust just big enough to take that power, 1 inch, we are going to see less noise and maybe even a slight increase in power. Yeah, there you go. We achieved a higher limit here. We improved the torque, Nice. We improved the loudness. We went. We The engine is not as noisy as before, and the weight is now also better. So very well. Okay, the engine is still running rich. Well, actually, it's running rich now because we toyed with the exhaust. So what we are going to do is to reduce the richness of the fuel, 3 points, and see what happens. We should have higher torque. Perfectly, yeah. Huge improvement in torque. We are very close to goal here, only 60 points, so let's make it better. Still, we have some, it's 90.3, we have 2 points here to toy with. So, what I want to do here, how can we increase torque without messing too much with, no spacing, no fuel system. Okay, we can toy with the ignition time and increase it a little bit. The higher ignition time is, the higher octane rating you need. Ignition timing is basically the timing of the spark plugs. So the spark plugs can ignite the mix just as the piston goes totally up, or before or after the piston reaches that point. Ideally, you want to ignite the charge as soon as possible, because then you give it time to burn perfectly and without knock. The thing is that if you try to burn it too early, there are going to be problems because knock is going to ensue. If you try to burn it too late, you are going to have problems because you will not achieve the same power, and the fuel economy is going to be worse. So, well, let's see what that did and if we will have knockback problems or not. Hopefully not. Well, for starters, we are getting better torque again, so that's good. No knock, no knocking at all. But our MTBF went lower, so it degrades the engine a little bit more in time. So let's make it better. MTBF. What can we do to improve this? Well, MTBF is a very important thing, but manufacture time is also one. Let's try to do something. Let's try to do this with cast pistons. That should reduce the man hours a lot. And hopefully we have no trouble with torque. I mean, it's not a lot, it's only 147 newtons. Perfect. We achieved gold. We achieved gold. So we have already done it really well. Platinum is very far away. Let's see if we achieve it in few time, and if not, I'll wrap it up and show you something else, and that will be it for this video. Okay, we don't have a lot of fuel octane rating to toy with, so we can't really increase ignition timing anymore. Let's see if we can increase our cam profile a little bit to normal. That should decrease our octane rating. And this will give the torque, the higher torque output at higher RPM. The thing is that it should peak before 3000 RPM. If it peaks later, I'm going to have to turn it down. Okay, perfect. It peaks here. The engine is running rich, no big deal because we can lean the mixture. Torque has gone down, but fuel system, the engine is running too rich. We are going to reduce it by 3 points, and we are going to increase the ignition time. No, maybe not that much. I don't want to go over the top. Let's test it again. And see what happens. Okay, torque is back up in the place it should be at. Success. Okay, we improved the MTBF. Torque is a little bit slower, but we are going to deal it in a second. Make it better. Fuel octane is very close to what we are going to have. Okay, wake. We can't really reduce the wake a lot. Can't we? No, no. We simply don't have the materials to do it simple. Um, okay, what I'm going to do is to increase the cam profile a little bit, because we still have a 3000 RPM to toy with. Let's see what that did. Okay, it peaks after 3000 RPM. That's too high. Oh, no, 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 no. Let's go back. Let's reduce it by 2. Test again. And see how it goes. It peaks here. Okay. We still need to decrease it. I think I was in the sweet spot, to be honest. Let's do it again. I think I was squarely in the peak, in the perfect position for the cap, for the cam. Yep, there you go. Peaks at 2700 RPM. There is the point. We can't really change that anymore. Next rank, Platinum, we are only 160 points away. Whoa, that's a lot. What can we do to improve this? Wake, we can improve a lot. Loudness is not going to be worth it because it's only a 5% of this. Increasing torque is going to cost us in manufacture time and MTBF. MTBF should be our concern. Let's see if we can improve that. I don't know. Let's see if we can go with lower RPM. I mean, we have a limit of 3000, but it doesn't mean we have to reach it, does it? A lower RPM means a longer lifetime for the engine. And we were picking the torque at 2700. There you go. And that should give us a small increase in that. There you go. Yeah, it increased. Perfect. And it also helped us with fuel octane rating a little bit. So let's increase the ignition timer by a factor of 3 or 4. So 4 should be enough. Well, at least enough not to give us problems with knock. Now, if we increase the timer, the torque limit goes over here. And we are actually getting bad results. So let's reduce it by a couple of points and see what happens. Okay, it's back at 2700. That's good. How are we going to do this? Standard? Noise reduction pretty high. Airflow low. We don't need a huge lot of airflow. Let's see if that works. We might get slightly lower torque out of that. Yeah, we did. A loss of 5, but we'll see the rest. Nah, Nah, that really did no good for us. A single barrel? Fuel efficiency very low. No, we need a 2 barrel. Well, we don't have any fuel efficiency rating here. We don't really need that. Let's see if that helps us. Because we are saving in... Nah, no. That's not helping. So we really need a 2 barrel. Well, single barrel twin cam. No, but that's to manage higher powers. So no, we need a 2 barrel. So we can't save anything here. Oh shit. Okay, I'm guessing that here we should start trying with different bulbs and strokes. Um, Maybe a bigger engine. Let's try increasing capacity to 2 liters and see which effects it has. Okay, let's do that. Okay, let's see. Weight is higher. That's going to cost us a little bit. But power is much higher, of course. But still, MTBF went down. Um, okay, let's do this way. This should reduce the total size and weight of the engine. We are not running at very high RPMs, so a big stroke won't be a problem. But nah, increasing torque is not worth it. Let's go the other way. Let's try to with a smaller engine. Let's try 1 liter and see what happens. We actually solved this. We already have the goal, but I'm trying to see where and how we can improve our... No, that's not going to give us enough power. But I think it's the way to go because you can see the MTBF has gone up. So let's do a couple more tries, and if we arrive somewhere, let's increase it to 1.3 liters and test it. If we hit 100 newtons, but we are increasing the weight and MTBF, it's so close, it's so close, we're almost there. MTBF is still very good, economy is very good, fuel octane rating, we let's increase the ignition time again. Let's see if that helps us with the little gap we need to reach 100. And by the way, we really need 3000 RPM. Okay, let's do that. That will give us the torque we needed. Of course, it's going to have a problem with the MTBF, but there you go. We increased. There you go. Weight is so lower that the loss in torque is more than compensated. So yeah, I think this is the way to go. Now, of course, we can try to increase the torque by other means and keep on going until we reach platinum. I'm not going to do that. So yeah, well, I'm going to do that, but not keep this up because I could be all night long with this video, and that's not the point. So yeah, you can see here how the thing works. But now look at this. This is still not working. This is where you are going to design your car. You're going to design your chassis, your body, your everything. And hold on. That you can see, you will have tail lights, indicators, cutouts, vents, everything to put in your car to make it look better. And finally, I don't know exactly where it was. Hold on a second. Well, you can select different bodies, and then you can. Oh, actually, I can. You can do it. Oh, I didn't know this. Oh, cool, cool, cool. I didn't think this was working. You can do it, but still, you can't mount the engine, I guess. So what you can do here is to change the shape of your car the way you want. Oh, I didn't know this was working already. Of course, this is only for those who have the pay version, I'm guessing. Oh, this is so cool! Nah, this doesn't look nice, and this looks even worse. Let's try to do it a little. Oh, how cool is this? I'm going to spend so much time. Look at that! You can change everything you want. The windshield position. That looks pretty crap, to be honest. Let's try to do a little bit. Oh, this is so cool! Oh, yes, yes. I'm going to spend so much time doing this. Okay, I didn't know this was operational, and well, I still have to figure out how to make things look nice. But yeah, you can see that different styles you can totally change to shape be shaped the way you want them to look like. So yeah, that's really it. What is? I haven't tried this. I haven't really tried this. And then I'm guessing you can headlights. Can you put headlights? I'm guessing not yet. I don't know. Oh yes, you can. What? Okay, guys. I don't know. I haven't tried this yet, but this is so cool. Okay, guys. This is Automation so far. Probably I'll make another video when I figure out how to design bodyworks and cars and stuff. I thought only the engines were working. I hope you enjoy, guys. I hope you really had fun watching this. Thank you very much for watching. Let me tell you, let me know what you think about this video, about this game. I'm going to include a link down below in the comment section so you can visit the web page of this game, and if you want to try the beta, do so. Again, thank you very much for watching, and see you later.